a shift. Okay, so back to now looking at functions, a rational function f of x is equal to 1 over x. If it has this form and then shifts, we just saw that that's super easy. However, not all rationals are a shift from the parent function, and so there's a lot more to think about. To graph it, we've got to kind of come up with some steps, which is what we discovered last time, right? Was the steps, some key features of our graphs. So it says right here, a rational function is a function you can write in the form f of x is equal to p of x over q of x, where p of x and q of x are polynomial functions. That makes sense. A polynomial function over a polynomial function. Then it says the domain of f of x is all real numbers except the values for which q of x equals 0, which makes sense. Isn't our domain everything except what would make the denominator 0? True? And that makes complete sense here. So now what I want you to look at with me is just 3 graphs of 3 rational functions. Now how can we tell that these are not a shift from the parent function? There are multiple x's in the equation. Didn't we learn that that's how you know it's not a shift from the parent function from before? Okay, so notice none of these are a shift from the parent function 1 over x. So what I want you to look at with me is a few key features. One of the key features we realized last time was x-intercepts. So where did our x-intercepts come from? Anyone else? The numerator. Our x-intercepts came from the numerator, right, everyone? Okay, so let's look here. We solved the numerator. So right here, x equals 0. Is that where it's crossing the x-axis? Yeah, right? Okay, and it had multiplicity of 2. So what's it actually doing? Bouncing at that point. Does everybody see how it makes sense? Okay, awesome. Now looking here, still looking at this, we learned that we get vertical asymptotes. So vertical is this. Vertical asymptotes and wholes from the denominator, right? So if we look here, if we factor our denominator, x squared plus 1, x squared plus 1 does not factor. Therefore, if we were to try to find these restrictions, we'd say x squared plus 1 cannot be 0. Subtract 1. X squared cannot be negative 1. Square root, square root. X cannot be plus and minus I. Do you guys see how this restriction is I? Therefore, there are no restrictions, because restrictions come from real numbers. Does everyone understand? We're going to be graphing on an XY axis, which is real numbers only. Now that makes sense. Look at the graph. Do you see any vertical asymptotes? No. Do you see any holes? No. So that is considered a continuous function because there are no discontinuities. Discontinuities are what make the denominator 0, which are vertical asymptotes and holes. Does that make sense, everyone? All right, let's look at this next one. We're just looking at key features for right now, not the whole shebang. Okay, so let's look here. We have a discontinuity at x cannot be negative 2. Is it a vertical asymptote? No, because don't the x plus 2's divide out now? So we have the equation y equals x plus 3, which makes sense. Look, here's our line, x plus 3. Look, y-intercept of 3 and then a slope of 1 over 1. You guys see how it's up 1 over 1? Now we have a hole at negative 2. That makes sense. Look, at negative 2, I have a hole. Now the problem is, if I didn't give you a graph, this is what you have to discover. So you would say to yourself, I know it's a hole at x equals negative 2. The question is, how high up or down do I go? Like, where exactly is the hole? So how do functions work? Well, plug in values, correct? Plug in negative 2. If I want to know what's my function at negative 2, I just plug it in. Now think about this. You have to plug it into the simplified function. Otherwise, aren't you just going to get undefined? Okay, so if I divide out x plus 2 and then I plug in negative 2, what's the y value? 1. So my hole is at negative 2 of 1. Does everyone see how to find the y value of the hole? So from here on out, holes have to be listed as x, y points. Great. Now let's see if our other key features here are happening. What is the x-intercept, since those come from the numerator? Negative 3. Is it crossing at negative 3? Yeah. So everything's working out what we've learned so far. Okay, let's go on to this next example. X plus 4 over x minus 2. Our discontinuity is x cannot be 2. Now it didn't divide out, therefore there is no hole, and there is just a vertical asymptote at positive 2. So then from here, is there an x-intercept? Yes, it would be at negative 4, right? Doesn't it cross at negative 4? So it's all making sense. Now, one more thing that I want to just review on is behavioral and behavioral horizontal asymptotes. So So just a reminder, the horizontal asymptotes are on the horizon, the far left and right. Where is your graph approaching? So where would you guys, if you, from the graph here, where would you say that on the far right and left, what value is it approaching? 1. So y equals 1 appears to be the horizontal asymptote. Do you agree? I agree as well. Okay, good. Now, why do we actually know that that's true? Because look at the equation. X squared on top, x squared on bottom. The degree on top and bottom are the same. So then you can divide your leading coefficients. 1 divided by 1 is 1. So we got it from there. Yes. We'll review that in more detail in just a second. I'm just briefly going over this. Okay, let's look at this. All right, so let's look back at this one right here, for example. Where is our horizontal asymptote? 1, which makes sense. Degree 1 on top, degree 1 on bottom. Divide your leading coefficients. 1 divided by 1 is 1. Does everyone see how it's working? And behavior. Okay, awesome. So what I want us to do right now is just make sure we're good with our discontinuities, our vertical asymptotes and holes. So everybody, here we go. Look at these examples with me. Then I'm going to set you free to work on the homework for a moment. So let's list out our discontinuities. Discontinuities come from the denominator being 0. So what is my discontinuity? X cannot be 3. Now, is that a hole or a vertical asymptote? It's a vertical asymptote, but x equals 3 because it doesn't divide out. Holes, this one has none. Any questions on that? Okay, right here, my discontinuities. X equals 3. Okay, it happened twice, but we only need to list it once. Are they vertical asymptote? Is it a vertical asymptote or hole? It didn't divide out, so it's a vertical asymptote. And my hole, once again, I had none. Okay, I'm changing this problem right here. This is what it was supposed to be. I forgot to write down the x. My discontinuities are x cannot be 0 or 2. My vertical asymptote is at x equals 2. I have a hole at x equals 0. True? So now watch, listen, because people didn't listen last hour. I divided out, because doesn't a hole divide out? Yes, so now I have a new equation. X plus 4 over x minus 2. All right, holes have to be written as xy points. xy, so now I know it's at 0. Now don't I plug in 0? You got to plug it into this simplified function, which is x plus 4 over x plus 2. So that would be 4 over negative 2, which is at negative 2. So I know exactly where the hole is at, 0 down 2 units. Does that make sense to everyone? Okay, great. So what I want you to do is go to your homework, and you're going to go through and just do a couple of these. Find the discontinuities, holes, and vertical asymptotes. You are not doing horizontal asymptotes right now, everybody. You're doing discontinuities, vertical asymptotes, and holes. Skip the horizontal part for a minute. I want you focusing here for a second. This is important to remember with horizontal asymptotes. They are technically called end behavioral asymptotes. It only matters on the end behavior. That's where your horizontal asymptote, that's the value it's going to approach. So if you look here, if we have the degree on top and bottom, and it's the same exact degree on top and bottom, you can just divide out the degrees perfectly, and we're going to get our leading coefficient is going to be our horizontal asymptote. Now, once again, I want to try to make sense of why this is, okay? So everybody look, I'm just trying to figure out where my value is approaching as I go to infinity. So I plugged in a big number. 1,000 is actually not that big, but let's look. We have 2 times 1,000 squared. Now, if I add 3 to that huge number, the plus 3 is not going to make a big difference, correct? It is there, but is it really going to change the number? Not really. So that's why I can ignore it, okay? Now, on bottom, I have 1,000 squared minus 1. 1,000 squared minus 1 is pretty much the exact same value as 1,000 squared. You all agree? Minusing 1 off of it is the exact, not exact same number, but almost the same value. Do you agree? All right, so then what's going to happen? Essentially, our 1,000 squareds will divide out perfectly. Then that will leave us with a 2. Now, is it 2 exactly? No, because wasn't there a plus 3 and a minus 1? Or approaching 2. Does everybody see what I'm saying? We all know it's not okay to divide across addition signs and subtraction signs, but that's not the point. It will approach 2. If you were curious, you could plug it in and you hit enter in your calculator. It really will say 2.000000003. You guys see what it's saying? So y equals 2. So the degrees are the same. Divide out your leading coefficients. So then you would have a horizontal asymptote at 2. All right, so if the degree on top is smaller, than the degree on bottom, it is going to approach 0 every time. Now this is the one time I really want you guys to, this one time, take your calculator, everybody do it. A lot of people that are not understanding this is gonna hopefully help it click for you. Now, as you type it in, make sure you use parentheses up here on your calculator and parentheses down here. Otherwise, it's not gonna do it in the correct order. So I'm showing you why it's 0. Let's plug in a big number, 1,000. So if we type in 1,000 minus 3 on top, in parentheses, divided by 1,000 squared plus 1, I want you to hit enter so we can see what decimal that is. Do you have it? Oh. Is there an E? E means times 10. So what is the decimal? 0.000000 what? 9. Isn't that pretty much 0? Do you guys see how it's calculating to be pretty much 0? Does that make sense, everyone? Okay, well that makes sense. Look, if you take and plug in 1,000 right here, you have 1,000 minus 3 on top. What matters is the 1,000 divided by 1,000 squared. 1,000 times 1,000 is a huge number. So you're taking something small and dividing it up a ton of times, a huge amount of times. If you take something and divide it up a huge amount of times, that's going to become 0. Does everyone see? Pretty much 0. So once again, if the degree on top is smaller than the degree on bottom, it is always going to approach the horizon at 0. Now, can it still have an x-intercept? Yes, because it can cross a horizontal asymptote, everybody. So don't let that freak you out. Does that make sense? Horizontal asymptotes are clear out here on the horizon. Where is it approaching? If it crosses a horizontal asymptote, like let's pretend it came down and it crossed, it'll just then hug it underneath. Okay, awesome. Okay, now one more thing. When the degree on top is larger than the degree on bottom, it actually can be divided. Like we can physically divide that type. That's going to create no longer a horizontal asymptote. It will not be horizontal, but instead it's going to be a slanted asymptote or a quadratic looking asymptote. So that does happen. So in this example, that always happens. If the degree on top is larger than the degree on bottom, it will divide out to be, it's called oblique. Oblique asymptotes are slanted asymptotes. This is what we're going to see most often, slanted rather than quadratic. So look at this, for example. X squared minus 5x divided by x plus 1. Degree on top is larger than the degree on bottom. What's x squared divided by x? X. Do you guys see how it divides perfectly? Do you see what I'm saying? Divides perfectly the degrees. So we actually have to go through and do long division or synthetic division to figure out the equation of the line or the equation of the quadratic. So can't we use synthetic division? If you have a coefficient of 1 and a degree of 1, you can use synthetic. So I'm going to use synthetic, -1. I put a 1, then a -5, then a 0. So now add straight down, multiply up, add straight down, multiply up, add straight down. So now write the equation of your line. Degree 2 divided by degree 1 is degree 1. So we have y equals x to the first minus 6. Now our remainder is plus 6 when we divide by x plus 1. Now the question is, there it is. There's the equation to the line. We're going to go graph this. Now everybody, this throws people off. What about this remainder? How do we graph a remainder? Well, is that going to be, when we start plugging in big numbers, is that going to matter? Let's think about it. Plug in a million. What's 6 divided by a million? Pretty much 0. That is not going to affect your graph very much. You can ignore it. You're not going to graph the remainder. You only graph the part that really matters. Does that make sense to everyone? So we go up. Our y-intercept is plus 6. Is it? Oh, -6, my bad. And then our slope's up 1 over 1. Up 1 over 1, up 1 over 1. And there's your slanted oblique asymptote. It's not horizontal, it's slanted. So what will happen is your end behavior, wherever your graph is, it'll approach, it'll just follow this, it'll follow it. Which I don't have the whole graph, so I'm just trying to make a point here. Okay, awesome. Here we go. This is number 1 on your homework. We're going to go determine the behavioral asymptote. So that means, is it horizontal or is it oblique? Well, let's go look at our degrees. These come from the degree. Degree on top and bottom are the same. Therefore, we divide our leading coefficients. So our horizontal asymptote is at y equals 3. Now, what if on the test you were like, I don't know. Could you plug in 1,000 and see what it becomes pretty much? Yes, it's going to become 3 pretty much. Okay, great. All right, questions. Okay, let's do another one. Number 2, what is the behavioral asymptote? Is it horizontal asymptote or oblique? The degree on top and bottom are the same, so it's horizontal, and it's y equals 1/3. Divide your leading coefficients. Very good. So again, number 3, what is the behavioral asymptote? Horizontal or oblique? It's not oblique. Degree on top is smaller than the degree on bottom. You're going to be cutting it up a lot of times, correct? 0. So 0. We have a horizontal asymptote at y equals 0. All right. And number 4. This one is an oblique asymptote because x squared divided by x is x. So you'd say, okay, I'm going to have to go ahead and actually divide this. So I'm going to use synthetic division again. 4, 1, negative 2, 5, add straight down, multiply up, add straight down, multiply up. Does the remainder matter? Not for the context of this problem. So there's your equation of your line. We took degree 2 divided by degree 1, giving us degree 1. So this is x plus 2. So y equals x plus 2 is your oblique asymptote. Your slanted asymptote. Awesome. Makes sense. Okay, I'm going to have you practice a couple more on your own. Well, actually, let's go do this one together. Number 11. So everybody, degree on top is larger than the degree on bottom, so it does divide out, giving us an oblique asymptote again. Let's go do long division with this bad boy. We have to. Now, we could simplify, then do long division. So what can we divide out? X. So then on top is x squared minus 5x plus 6. And then on bottom one, we just have 4x minus 12. Okay, awesome. Okay. So we can do it with either. We'll get the same answer. So on the outside of our house is 4x minus 12. On the inside of our house is x squared minus 5x plus 6. Divide your leading term, x squared divided by 4x, which is 1/4 x. Now we'll take 1/4 x times it here. That's x squared. 1/4 x times negative 12 is just simply negative 3x. Now you change your sign, add straight down. That would be 2x plus 6. Divide your leading term, which is 2x. 2x divided by leading term, 4x, gives me 1/2. So plus 1/2. Now we know the last part's going to be our remainder. Once you get y equals mx plus b, the last of it would have to be the remainder. Do you agree? Yes? What do you mean, divide out the 4? No, because the top didn't have a 4 to divide out with. Okay. I want it, and here's what you're asking. Why don't we factor it? So when you do long division, you're going to want it in standard form. Okay. Good question. Okay. So now from here, we know that's once you have mx plus b, the rest has to be the remainder. So your oblique asymptote is the equation 1/4 x plus 1/2. Okay, that's my last example for a moment, because now we want to actually graph these, and I have a lot of examples, so I can only give you another couple, like 2 minutes to practice a couple before I start graphing them all the way. Shoot, so we need to change our sign? This should have been negative 2x, so this should be negative. Okay, good catch. Good catch. All right. So practice a few by yourself. Ready, go. I'm going to have time to write it down. So what is the rational function is not a shape on the function because it's I factor everything. I always use standard form and factor form. There are things when I use both. And discontinuities or asymptotes and holes. The denominator. Third, I find horizontal or behavioral asymptote. And fourth, it's intercepts and fill in the graph. Now, what you need to know is my graph complete based on your domain. Okay, so domain is everything except our restrictions. So your graph should connect all the way through. You'll see what I mean with some examples. Okay, all right, so here we go. So this is my first example. So it says graph. So you say negative x minus 2 over x plus 3. I'm going to factor that. It's factored. Okay, great. So now we're going to find our vertical asymptotes and holes. Okay, vertical asymptote is that x equals negative 3. So I go in and graph that. At negative 3, I put in my vertical asymptote. Are there any holes? None. Moving on to Horizontal asymptote, degree on top and bottom, I like standard form. Degree on top and bottom are both 1, so you divide your leading coefficients, giving me y equals -1. So now I have that. Now the next step I do is just from here, guys, all we're essentially doing is plotting points, figuring out where the graph is. Now we're going to try to think advancedly so we can do as little work as possible. Let's find our x-intercept. I always find x and y-intercepts, or maybe usually for sure x-intercepts. X-intercepts come from the numerator, don't they? Negative x minus 2, solve it. So then add 2, negative x equals 2. So x equals, so -2, 0 is an x-intercept. -2, 0. Now that's all I need on this half of the graph because I'm drawing a rough sketch. We know that it's up here in this, I don't want to call it a quadrant, but you get what I mean by quadrant, right? Quadrant 1, 2, 3, 4. Okay, so it's coming up by this asymptote and down by this asymptote, right? Now, make sure, once again, isn't our domain all real numbers except -3? Do you see a graph pointing this way forever? No, we don't even have graph. Either there's a graph up here or down here, correct? One or the other. So if we don't know, what could we do? Plug in a value for x. So I'm going to go on this side of my vertical asymptote and try to figure out, well, if I plug in -4, what is my point? So plug in -4. That would be 8 minus 2, right? 6 on top. And then on bottom, -4. So -1. So what's the point? -4, -6. So I know it's down right here. So it must be right here. Our graph must be down here. Now, could I have just thought about this? Instead, I should have thought more advancedly. That works, right? Got it. However, could it have been up here? No, because wouldn't it have then had another x-intercept? So we should have actually just thought about that. But it doesn't matter. You got the right graph. Does that make sense? Yes. Well, it depends. They're not always necessary. There are graphs where they're both up here. So yes, but we wouldn't have needed to for this one because that was the only x-intercept, and if it was up here, it would have crossed again. Does that make sense? Okay, awesome. Another example. Stick with me. We're going to build up to the hard ones. So first step is to factor the top, factor the bottom. So on top I have 4x. On bottom I pull out an x, and then wouldn't it be x squared minus 4? So that factors to be x plus 2. X minus 2. Okay, great. So my vertical asymptotes are at x equals -2 and x equals 2, right, everyone? So I go to -2 and put in my vertical asymptote. I go to 2 and put in my vertical asymptote. I have a hole at x equals 0. I divide it out, write down the new function. That's 4 over standard form. I want it in personally. That's just me. All right, so now to figure out the xy point where the hole is at, plug in where the hole is, which is in this case 0. So we get -1, right? 0 squared minus 4. Okay. So now I'm going to go ahead and in red, that since that's just an xy point on the graph, I'm just going to do it in red. So over 0 down 1 is an open hole on the graph. Okay, let's move on. I'll come back to plotting more points after I get my horizontal asymptote. I go back to standard form. Degree on top and bottom. Degree on top is smaller than the degree on bottom, so it's going to be cut up a lot. So isn't that at 0? So my horizontal asymptote is at y equals 0. Now once again, guys, you should have graph on each side of your vertical asymptotes, right? It should connect from -infinity to infinity and skip over your asymptotes, true? So I'm going to now make an xy chart and plot some points. I'm going to start with plugging in something on this side of our asymptote, like let's plug in 3. So I want you guys to plug in 3 in just a moment. Now, what I'm also going to do is plug in something on this side, because it might be up here or the graph might be down here. So let's plug in -3. Then I need to know what's happening in this section here, like maybe between the hole and the asymptote, the hole and the asymptote. Maybe I'll need that. Maybe not. But maybe, let's see here, actually, okay, let's think about this. So you guys first go plug in 3, this half go plug in 3, this half plug in -3. Tell me what you get out. Then we'll talk more. I don't want to confuse people. Make sure you use parentheses and stuff, please. And you can just give me decimals. Decimals are easiest to graph. What'd you get? Right here or right here? Negative 3 is negative 3.8?
No. Negative 3, so y is 0.2.
Okay, cool. How about 3? No one has 3 yet? 0.8? Okay, cool. Okay, so let's go ahead and put those points in. I'm at over 3 up 0.8, check. I'm at negative 3 up 0.8. Okay, well then don't we know it's on this portion of our graph? Yes, right? Now the question is, okay, this actually could come down, follow this asymptote and cross, or it could just not cross and come around like this. So the question is there an x-intercept, right? Wouldn't that be the best point to look at? So remember, the simplified answer is here. Is there an x-intercept? No x-intercept. So is it possible to come up here? No, because then it would cross the x-axis. So it must swoop around like this. Cool stuff. A lot of times that x-intercept is really going to help you visualize where to graph it, because you'll know it can't be here because it can't cross or whatever. All right, let's do another one. Okay, so everybody, what I want you to do is we got to factor the top. Okay, we tried, it doesn't factor. Okay, then that's our top, right? X minus 2. Okay, so if it doesn't factor, then nothing divides out. So what's your vertical asymptote? X equals 2. So watch, every graph's different. That's why I'm doing so many examples. So many different things come up. Hey, was there any holes? No. And I'm going to go on to horizontal asymptote. The degree on top is larger than the degree on bottom. Dang nabbit. We've got to do long division or synthetic. Let's use synthetic. Okay, so we have a 2, a negative 3, and a 3. Add straight down, multiply up, add straight down. Now, isn't that all that matters? The remainder doesn't, so I'm stopping. So now we have the equation, y equals 2x plus 1, right? So you've got to be able to graph a line correctly. We do a y-intercept of 1, our slope is positive 2, up 2 over 1, up 2 over 1, up 2 over 1, down 2 over 1, down 2 over 1. Okay, so here is my dotted, slanted, oblique asymptote. All right, so now we've got to fill in our graph. Let's do x-intercepts. Well, actually, I'm choosing to not do x-intercepts for this one, because if the top didn't factor, x-intercepts are going to take the quadratic formula. No thanks. Let's do different points. You guys see what I'm saying? So we could do the y-intercept. Y-intercept is when x equals 0. I'm just picking points, essentially. Isn't 0 going to be in here? Or out here, just 0 might be up here, right? Or it might be down here. So let's see. If we plug in 0, we get 0, 0, 3 on top. And then we get 0 minus 2. So that's negative 3 halves, right? So 0 and then down a little bit. So we know, now can you see where it's going to be? Isn't it going to follow the asymptote? And it's going to, is there any x-intercepts? Maybe. So it could cross, but right, because it could be decimals from the quadratic formula. We're doing rough sketches though, so I'm just going to, we're not done though, still. But do you have a question on this portion? Yeah, but then we have more of the graph. How do I know? Look, on this side of the vertical asymptote, I have to have a graph, right? Isn't the domain everything but 2? You guys see how we don't have anything? There's got to be something either up here or down here. Does that make sense? All right, so let's plug in, I don't know, like a value in this section, like maybe plug in 3. Sure. So plug in 3. If you wouldn't mind plugging in 3, what does that calculate to be? 12. Okay, so over 3 up 12. That's up here, everyone. Does everyone see how that works? Does your domain grow from negative infinity to infinity? Yes, because isn't this going down like this? Like that. Okay. It's going down though forever, right? Okay. And then it's also going this way forever. Okay. Okay. Sorry, a lot of examples, but there's just so many different things. You haven't even seen something similar yet, you know? Can we do one more? Okay. So on top, it factors to be x minus 4 and x plus 2. On bottom, we pull out an x, left is x plus 3. So our vertical asymptotes are at x equals 0, x equals negative 3. There's a reason I have all these. They all just have different elements, and people, when they don't see examples, have a hard time with them. Okay, there we go. No holes. Let's go on to horizontal asymptote. The back to standard form. The leading coefficient, since the degree is the same, right? Okay, let's now find our xy points, right? I'm going to do x-intercepts for sure. My x-intercepts are 4, 0. Are we all with me? And -2, 0. Those are points on the graph. So over 4 of 0. So I know that the graph must be coming like this. And then over -2 of 0. Okay, now the question is, once again, is it going to cross and go up? Is it going to bounce back down? Did this have a multiplicity of 2? It's definitely not going to bounce. Can it cross and then cross again? No, or there'd be another x-intercept, right? So what has to happen? It must be coming up and crossing. Does that make sense to everyone? Now, actually, I should have been really careful because could I have actually gone like this? So what should I probably do? Plug in a -1 and see if it goes up or down. So if somebody would quickly plug in -1 with me. I guess we'll just do it real quick together. So that's on top, plugging in -1, you get -5 on top, and then on bottom you get, on bottom you get, so it is +5, right? -1, 5. So luckily I did graph it right. -1 times, okay, so it would, well, a negative divided by a negative is positive, right? Yeah, but then times 1, and then on bottom I have -1 times 2, which should have been not -1, but -2, which is still positive, so it's actually 2.5. So we're still good. Right?
Yeah.
Okay, now I need more graph, right? It's got to be either it's going to be here or up here. So how am I going to know? Well, question, let's use our brains here. I could test -5, couldn't I? Would that be wise? No. Are there any other x-intercepts? So it's not possible to be down here. It has to be up here. Does that make sense? It really helps if you can think of things like that. But if you don't, just plug in a value and you'll see where it goes. Are we all good? Many different elements. Okay, I do have, it's up to you guys, I have 2 more examples, but if you feel completely confident, I'll let you go. But if you want a couple more, we have a couple more. We have about 10 minutes left of class. Would you rather practice or watch a couple more examples? Okay. So this one's already factored. Great. So then this is going to be pretty easy. I have a vertical asymptote at x equals 2. Do you agree? So you go over to 2, graph that. Then you have a hole at x equals -1. Divide that bad boy out. Rewrite your function. That's -1 x minus 6 over x minus 2. Now we'll plug in -1. That's -1 and then -7, right? -1 minus 2 is -3. So our hole is at -1, +7/3. No, -7/3. Do you agree? Which is about what decimal? Let's just write down the decimal. -2.3-ish? Okay, good. Oh, great. So then from there, I'm going to go ahead and graph that. That's a hole. So at -1, down 1, 2, and a little bit. There's my hole. Great. Moving on. Horizontal asymptote. Go back to standard. Okay, no, never mind. Let's go back to right here. Degree on top and bottom are 1, aren't they? Degree is the same. So divide your leading coefficient. Our horizontal asymptote is at y equals -1. Your test is on my desk. Then from there, let's plot points. Now, question, what are the x-intercepts? So we're just plotting points. X-intercepts are 6, 0, right? It comes from the numerator, so over 6 of 0. So now we know exactly where it is, the graph on this half. Great. Now here, we have a hole, but isn't that just a point? So that is just like this point, but it's an open hole. So it must be like this. Do you agree? Now, if you don't know for sure, just plug in some values, everyone. Is this making sense? Okay. Now, why did I know it wasn't up here? Because there was no other x-intercept. So it's not possible to be up here. True? Okay. All right. Okay, so we do have, what do you want to do? There's actually 10 minutes now. Do you want another example or do you want to be done? Okay, that's fine. I actually have this one, and that's what I thought would be suffices to say that you'd be good to go when you get home. Okay, so on top, what does that factor to be? X, well, multiplies to be 12 and adds up to be -7. 4 times 3, negative, negative. X minus 4 and x minus 3. How do you factor those two perfect squares? That'll become 2x minus 4 and 2x plus 4, which I should have actually factored out the 4 from the beginning, because I'm going to pull out a 2 and a 2, and that's going to be 4. So I have x minus 4 on top, x minus 3 on top, and on bottom I have 4, and then x plus 2 and x minus 2. Should I pull out the 4 from the get-go? Does everyone see? Okay, awesome. So now you'd say, okay, my vertical asymptotes are at x equals -2 and 2. Where is my horizontal asymptote, people? 1/4, so about right there. Okay, awesome. Now we're just plotting points. What's my x-intercepts, if any? 4, 0, and 3, 0. So I'm going over 4 of 0 over 3 of 0. Yep, okay. Just felt weird for a minute. So, how is that happening? What's happening? What's happening? Right? What multiplies to be +12 and adds up to be -7, 4, and 3. But it can't bounce at any of those. That's why I'm weirded out. Are you weirded out? Like, do you get what I'm saying? I'm like tempted to go like this and then just like, but that's like bouncing, and that's kind of. So I'm missing something, but let's just move on and pretend we're not missing something. I'll figure it out in just a moment. We gotta keep going. Any other x-intercepts? So doesn't the graph have to be up here, everyone? Can it come down and cross again? No, so it has to be like this, doesn't it? Now, can it be down here? No, because that would cross again. You guys see what I'm saying? There are no x-intercepts besides 4 and 3. So then right here must be our graph. Now, what if you weren't sure? Couldn't you plug in more points? Okay, I'm curious. Would somebody graph this on their calculator? I don't know what's happening here.
I did. It's like super weird. Like,
can I see it?
So it curves down like that, and you're what?
Okay, we see our vertical asymptote. See, we're not. I don't know if our windows are in. What the heck? This is down here.
Yeah.
Oh! What? Okay.
Hasty. I got hasty with my guesses here. So I guess what we probably should do to make sure is actually. So I was thinking it had to be up here, but apparently it's just down here. It's still not crossing, and so I guess I shouldn't assume, but what I should have done is say, let's plug in 0. So guys, do like plug in 0, because that's in here, right? Plug in 0, and don't I get a negative number? So that's actually down here. Does that make sense? Well, we do know it's not crossing. And now the question is, what's going on this side of the graph? That's got to be what it is it's like coming down and it's like following at 0, and then, yep, that's exactly what it's doing. That happens. So, guys, that actually does happen. So can you cross the horizontal? Now, should I plug in, like, I could plug in a value to make sure it's not coming down out of here. I'm weirded out by this one because I'm being lazy instead of plugging in points. Like, do you guys see how right here I'm going to actually have to plug in a decimal? If you plug in 3, it's not going to work, right? We know it's 0. So I would have to plug in a decimal, like 2.5, and see where I'm at. Now, why? Because I just want to make sure. Do you guys see how I assumed it's up here? What if it was actually like this? You see what I'm saying? So 2.5. Or I could plug in like one of these and see if it's below or above. Wait. It's hard with graphing calculators because they kind of wig out sometimes. That's a weird fluke. Okay, this is my real last example. Do you want me to do it or not really? I'll be thinking about that last one. They'll work out nicely. Okay, vertical asymptote is at x equals -1 and x equals 3. At -1 and at 3. We're just missing something small on that last one. My horizontal asymptote is at 0. Isn't the degree on top smaller than the degree on bottom? Do we have any x-intercepts? No, look at the top. Okay, awesome. So then from there, you can make an XY chart. We have no x-intercepts. So what we can figure out where our graph is, like by plugging in points. So I'm just going to go ahead and plug in 0 because that's an easy one. So that would be 1/4 times 1 times -3. So that's negative, I'm plugging in 0 into the equation, right? So I'm just -1/12, which is over 0, I'm down a little bit, right? So we definitely are down here, not crossing and coming down. Now I'm going to plug in a 4, sure, plug in 4. So then that would be 1/4, and then 4 plus 1 is 5, and then 4 minus 3 is 1, so 1/20th. So over 4 up a 20th. So we know we're up here, not crossing. True? And then I'm going to plug in a value on this side of the vertical asymptote, like, I don't know, -2. So then that'd be 1/4 times -2 plus 1 is -1. -2 minus 3 is -5. A negative times a negative is a positive. So this is 1/20th again. So then over -2 up a little bit. So then my graph is up here. Okay, awesome. I'll be really thinking, contemplating what was going on with that while you guys are, you have 3 minutes till the bell rings. Yeah, I'm just not seeing something. I'm just forgetting something.